So I am going to go over VSEPR theory and mainly review it if you have covered it in a previous chemistry course. I am assuming that you have already reviewed how to draw a Lewis structure, and so you know the number of bonds and lone pairs around a central atom. So somewhere in our materials, you should have a worksheet or a document, a handout that has tables on it. It's set up a lot like this. And this is what I use as a reference. It's a very short summary of a lot of information. And how you use this is once you have your Lewis structure drawn, then you can determine the total number of domains around the central atom or whatever atom that you are looking for the geometry around. So you determine the total number of domains, and that number is here. And that's electrons in terms of electron lone pairs or bonded atoms. Those are domains. And then once you figure out that total number, then you only work in that one row and work across. So for example, if you have 3 domains, then your electronic geometry is trigonal planar because all the 3 groups will align themselves in a flat trigonal planar geometry. But if 0 of them are lone pairs, then both the electronic geometry and the molecular geometry are called trigonal planar. If one of those groups is now a lone pair, then you would call it a bent geometry. The electronic geometry is still trigonal planar because it's still in this trigonal planar family, but we have a related geometry called bent, or sometimes angular. And then if you have 2 lone pairs, it becomes linear. So that is a brief way of how to look at this to get the geometries. The bond angles are also drawn in and identified, and then the last column gives notes on how to interpret polarity in terms of electronegativity and the overall polarity of the molecule. So make sure you are familiarized with this, and then we're going to move into how to determine molecular geometry and how to look at mainly at polarity in terms of the VSEPR theory. All right, so we're going to start with our first row, which is a group of 2. If you have 2 atoms or 2 groups around a central atom, they are always going to spread out as far apart as possible and symmetrically, so they will be 180 degrees apart. All right, so you can look at each individual bond. If this is our bond and we look at the 2 atoms, if they are different, then they do not have the same electronegativity. Remember to review electronegativity and how that affects polarity, but also if they're different in general, they would have a different electronegativity and this bond would be polar. Then you would evaluate this bond. If these atoms are different, this is polar. Now, if the 2 outside atoms are the same, this electronegativity difference is the same as this electronegativity difference. And the best example that I can give you is if this is the more electronegative atom and these 2 are the same. It's kind of like tug of war with the electrons, and if they have the exact same strength or affinity for electrons, then this is going to cancel out. Nobody will win this tug of war, and this is a non-polar molecule. But if I have some sort of different atom on the outside, regardless of what the central atom is, if these 2 are not the same, then this becomes a polar molecule because now these strengths are different and somebody would win the tug of war. So this would be polar. So if the atoms are the same, it would be nonpolar. But if the outside atoms, the periphery atoms, are different, it would be polar. So if they're the same, let me make sure I said that correct. If they are the same, it's non-polar because they cancel out. If they are different, then they would be polar. Now, the next thing within the group of two, you can have a lone pair. So I'm going to use these short sticks to kind of represent the lone pair. I have two groups. They are still, that is going to be the linear electronic geometry, and they get as far apart as possible. That's 180 degrees. So that's the basic linear structure. But now we just have one bond, and if they are different, it is polar. If they are the same, it is nonpolar.